Okay, so our previous video ended unexpectedly. So quickly, we're looking at example 3, which says, what is the amount in mole of sodium hydroxide present in 150 centimeter cube of 0.5 mole per dm cube of sodium hydroxide? So firstly, when you see a question like this, you bring out your parameter. Obviously, this is not a dilution problem. This is not a reaction between two substances. So we know we're not using a dilution formula. We're not using CAVA over CDVB equal to N over NB. We're not making use of any of those formulas. We're making use of our normal formula for concentration. So bringing out our parameters, so what is the amount? So first thing you should notice is you're looking for amount. So the symbol for amount, which is N, we don't know. What is the amount of sodium hydroxide that is present in this volume? So we were given volume. So the volume will be equal to 150 centimeter cube. But depending on the formula I want to apply, if I'm going to be using the first formula, I must convert this to dm cube. So I will say 150 divided by 1,000 watts now, dm cube. So we convert that. So that would give us 0.15 dm cube. All right, then, so we have amount, volume, and then concentration was also given. So concentration, the symbol for volume is V, okay? Concentration, which is C, was given in the question to be 0.5 mole per dm cube. So this is what we know. So we simply use our formula that states that what concentration is equal to amount over volume in dm cube. Okay, so if we substitute in our values now, we're going to have that in place of concentration, we have 0.5 is equal to, in place of the amount, we don't know, so we'll leave that to the N. The volume we've converted to dm cube as 0.15. So by the time you cross multiply, you have that N would be equal to 0.5 multiplying 0.15. So that would give you that gives you 0.075 moles. So that becomes your answer for this particular problem. We'll move on to example 4. Okay, now let's look at the fourth example. The question is, what is the concentration in mole per dm cube? Take notes, so we are being asked the molar concentration. What is the concentration in mole per dm cube of a solution containing 0.1 grams of sodium hydroxide per 50 cm cube of solution? So what was given in the question? Grams signifies mass. So we are given mass. So for such problems, first let me tell you the formula I would make use of is concentration is equal to amount. In this case, they said the amount should be in mole, since the concentration is carrying mole per dm cube. So my amount, let me put in a bracket, specified mole over your volume, and my volume should be in dm cube. So let's bring that everything we have. We have mass. We don't have mole, but we have mass. So we have the mass was given. So the mass 0.1 grams. But we don't need mass because the question did not. Supposing the question was saying what is the concentration in grams per dm cube, I would have used this mass in place of the amount. But since the question said in mole per dm cube, you just have to recall that we have established that mole is equal to mass over molar mass. So we can now say our mass in the question is 0.1 divided by the molar mass of sodium hydroxide was given to us to be 40 in the question. So that's this number here represents the molar mass. So divided by 40, and this is in moles. So you punch your calculator, 0.1 divided by 40 divided by 40 would give you 0.0025 moles. So since we now have our amount in mole, the volume was given in the question. If you should read your question, the volume was given to us to be what? 50 cm cube. But remember, when you are using this formula, you convert your cm cube to dm cube by dividing by 1000 dm cube. So I think our volume becomes, if you punch your calculator, that should be 0.05 dm cube, right? So if this is what we have, we can now come back to our formula and say, therefore, our concentration, which is C, concentration will be equal to my amount, which I've gotten to be 0.0025 divided by your volume, we've gotten to be 0.05. So this is now in mole for the denominator per dm cube. This for the numerator, and then the denominator is in dm cube. So you punch that in your calculator quickly. So we have 0.0025 divided by 0.05. So that gives me 0.05 mole per dm cube. So that's your molar concentration. Now, if you don't want to go through this long route, you simply make use of the formula I gave to you, which states that what? Molar concentration is equal to mass over molar mass times 1000 over volume. But remember, if you are using this formula, your volume should be in cm cube. You don't convert when you are using this formula. So let's punch in that. Directly, the mass was given to you to be 0.1. So that's 0.1. The molar mass was given to you in the question to be 40. Then times 1000 over the volume in cm cube is 50. So you make use of the 50 just as it is there. So you punch your calculator, 0.1 times 1000 divided by 40 times 50. So that also gives you the same answer of 0.05 mole per dm cube. So this is mole per dm cube. Mole per dm cube, yes. So in case you are wondering, how did we know that the units will be in mole per dm cube? It's simply because this is molar concentration. Molar concentration implies mole per dm cube. So we'll move on to example 5, which might be the last example, or two more examples, I will call it a day. All right, now let's look at this fifth example together quickly. How many grams? So we're looking for mass. Take note, just know how to pick out your parameters. So how many grams of sodium hydroxide would be needed to produce 100 centimeter cube of this? So what do? Bring out your parameters. We are given volume. This marker isn't working properly. Let me have a second marker, please. Quickly, quickly. Thank you very much. All right. So we are given the volume. The volume of the solution was given to be 100 centimeter cube. So depending on the formula I want to work with, you can choose to convert. If I'm using the first formula, so if I'm using the first formula, that's going to be 100 divided by 1000 dm cube. So that gives you 0.1 dm cube. So we've gotten our volume. We are given the concentration. Whenever you see mole per dm cube, Remember that is molar concentration. So we are giving concentration. Oh, we are giving the concentration, which is C. We're giving to be 0.20 mole per dm cube. Okay, but then we are not given the amount. So the question says how many grams. So the amount wasn't given. The amount is unknown. So you simply write a formula. The symbol for amount is N is unknown. So we all know that concentration is equal to amount over volume in dm cube. This is the formula I've given to you. So from here, let's substitute. We can say in place of amount, which is your concentration, was given to be 0.2. You say equal to, the amount is unknown. So you say N divided by, your volume was given to be 0.1. Take note, your amount in this case is not in grams, it's in moles. Why are we saying so? Because this concentration is molar concentration, which is mole per dm cube. So by the time you cross multiply, you are going to have that N is equal to 0.2 times 0.1. So 0.2 times 0.1 times 0.1 would give you 0.02 moles. But then the question did not ask us how many moles. If that was the question, we would have ended there, but it said how many grams. So we need a formula to convert this mole to grams. And what formula is that? You just have to remember that mole is equal to mass over molar mass. So if we substitute, we got 0.02 for the mole. So we say 0.02 is equal to, we are looking for the mass now, divided by the molar mass of sodium hydroxide already given in the question to be 40. So that's a constant. It was given to us. So when you cross multiply, you have that your mass would be equal to 0.02 times 40. So you punch your calculator, 0.02 times 40. So that will give you 0.8 grams. Mass is in grams. So that's your answer. It's as simple as that. Now, if you don't want to go through this route, as usual, any question that have to do with molar concentration and then mass, you can use the formula given to you, which states that molar concentration is equal to mass over molar mass times 1000 over volume. The volume here should be in cm cube, remember. When you are using this formula, your volume should be in cm cube. When you're using this first formula, your volume should be in dm cube. So by the time you substitute, your molar concentration was given to you in the question to be 0.2. So 0.2 would be equal to, the mass is what we're looking for, how many grams. So if I take that to be x, we're looking for the mass divided by the molar mass already given here to be 40, then times 1000 divided by your volume was given to be 100 cm cube. You don't need to convert that. So with that, we can just say 0 cancel 0, 0 cancel 0, this cancel this. So what is left now is, all right, I've gotten the board Y. So let's take a little space off. So with what we have here now, we can now see that from here, what's left is 0.2 is equal to x over 4. So by the time you cross multiply, we can now say that x will be equal to 4 times 0.2, which will give you same answer, 0.8 grams. So it's advisable for exams that are time conscious, you just make use of this second formula because it's shorter than the first approach. So we'll do just one more example and we'll call it a wrap formularity. Okay, so now we look at this last problem. Now, this problem connects molarity that I just explained with problems that involve what now? Reactions. You can see an equation and then you can see the concept of molarity playing out in this line of the question. So let's read the question with understanding. They said calculate the mass of zinc tetraisophosphatate 6. So I told you for such problems, always focus on what was mentioned. So we're calculating the amount. Okay, not just what was mentioned, those species whose amounts are being mentioned are being made relevant. So we have this, calculate the mass of that produced when excess of this. When you see excess of a substance, it means we don't really care about the amount of this. Now it means we put excess of this. So we're not making use of this in our calculation. So when excess of that is added to 50 cm cube of 4.0 mole per dm cube of this acid. So now, in such problems, if they give you a problem involving a reaction, and then you see a line involving molarity, you have to analyze this line and get the mole, the actual amount of the acid that is present in the 50 centimeter cube of this. That's the first thing you should calculate. So how do I do that? You simply make use of a formula that says what? Concentration is equal to what now? Amount over volume in dm cube. Remember, volume in dm cube. Whenever you're working with this formula, this is what you say. Now, bringing out our parameters now, where the concentration of the acid was given to be 4.0 mole per dm cube. And then the volume was given to us to be 50 centimeter, 50.0 centimeter cube, which we convert by dividing by 1000 dm cube. So our volume becomes 0.05 dm cube. So now that we've gotten this, we can now plug them into our formula and say in place of concentration, we write 4.0 is equal to N, which is the amount. We don't know the amount. Remember, the amount now is in mole. How did I know? Because the concentration is having mole per dm cube. So equal to amount over your volume is 0.05 now. So you quickly punch your calculator now. When you cross multiply, you're going to have that N would be equal to 4 times 0.05. This is in moles. Okay? So punch that in the calculator will give us our answer in mole. 0.2. So we have 0.2 mole. Now, since this is what we have as our mole, we can now return back. So whenever they give you a question involving a reaction and then they give you a line that brings out molarity, you first of all get your amount from the statement. After getting the amount of the acid, this is actually the amount of the acid that is reacting. That is what it means. So we can now go and say from the equation, you can state your stoichiometry now. So you say from the equation, so we are stating a stoichiometry between the acid and ZnSO4. So we say from the equation, this is 1 mole, according to this equation, 1 mole of H2SO4 actually produced 1 mole of this. But remember what they asked us about ZnSO4, which is zinc tetrasulfate 6, is not mole, it's what? It's mass. So instead of me writing 1 mole of this, I should be asking myself, what is the mass for this 1 mole? And it was given to me to be 161 gram. So I can say 1 mole of the acid produced 161 grams of ZnSO4. Yes, so this is my stoichiometry. But now I have discovered that in this reaction, the amount of H2SO4 that reacted is not 1 mole, rather is 0.2 mole. So I will say 0.2 mole of H2SO4 would give you X. So we are looking for this mass. Are we together? Okay? Okay, so quickly from here, you cross multiply like we always do. X will come and multiply 1. So my answer becomes X would be equal to zero point 0.2 now. 0.2 would multiply 161. So grams. So our answer now, calculator, punch. 0.2 times 161 would give us what quickly? 0.2 multiplying 161. 32.2. So we have 32.2 grams. So this is the mass of zinc tetraoxide 6 that was produced when 0.2 mole of the acid reacted. So this brings us to the end of this series of molarity mass volume relationship. If you have any question regarding this topic that you don't understand, please drop it in the comment section. Remember to like, to share, and to subscribe. I'll see you in my next video.